Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
I've been thinking a lot about how badly null is explained in programming. And for me too, it's like only recently have I really started looking at that going, oh, that means this. Because I came from C and assembly and C++. And initially it was just either uninitialized or set to 0 or whatever. And it was just like, yeah, don't do that. Don't use that.
Yeah.
And not like what Bill encounters a lot is people not paying attention and ending up with null pointer exceptions in Java.
Yeah.
And when you really start looking at it, you're going, well, what are you trying to convey with this null? And you realize, but it wasn't until I started looking at the optionals and ethers and all the monadic things where they're going, we have more information to convey here than just the result.
Yep.
And then you look at the way Kotlin does it, and it seems a little strange at first because they do all this trouble to get rid of the nulls that they get from Java, and yet their model for results is result or null.
Yeah.
And going, well, what's up with that? And it's like, well, that is kind of pseudo-monadic way of doing it.
Yeah, it's definitely the ADT, the algebraic data type, for modeling if something has a value or doesn't, is you join together the two types with it would be a or expression in algebraic data types. So this is a dog or a nothing.
Mm-hmm. Right. And then the Zio stuff says, well, as long as we're sending this package along, maybe we want to add some other things that everybody needs to have. And it's like when you start thinking of it in terms of these packages that are being transferred from one function to another, to me, it starts to make sense.
The chainability is critical to the whole thing.
That's
because
the essence of it.
If you only ever call one thing, none of this really matters.
Nope. It's all about composition.
Yeah.
It's like either you're doing these chains or you're composing a new function by putting these other things in, and you don't want to have to insert after every single call. You don't want to have to insert, did this succeed, or and then once you realize that that's an option to have this package of information that flows, then you can say, oh, well, maybe I want something from the environment or something for the user interface that I'm talking to, or I think Bill's using time that way.
Yeah.
And now it starts to make sense. Yeah. And I think that the monadic idea is just, that part is just, okay, if you want to do this, can we have math that shows us what is the right package to ship between these two things? So this is just my thinking right now. I don't know if that's right.
Yeah. What are the expectations that this thing conveys?
Right. Exactly. And what the problem that happens is people get fascinated with that and they say that's the essence of it. And that's not. It's the composability, chainability thing that is the essence of why we're doing this at all. And I couldn't understand it because I didn't know what the motivation was.
Right. I just saw a tweet this week that showed a block of code that was like a block of code that you would see in so many books and samples. It was like, okay, I'm going to talk to the database. I'm going to get a person, and then I'm going to use that person to look up some other piece of data about them. And the interesting thing about that example and what was pointed out was that code will never be production quality code because it doesn't address the potential for failure. It doesn't address the potential that the person couldn't be found. It didn't address the what happens if the network is unreliable and I need to do a retry. It doesn't address dependency injections, the ability to change how I do that lookup based on my environment. Testability. And so it was really an interesting example of why our programming languages are adding features or changing the way that we do things so that we can have the conciseness of that code, but also deal with the issues with actually putting that kind of code into production.
Because and this is the way we teach programming. We teach happy path programming.
Yeah.
And that's the way I learned it. And I still remember like encountering a C library that says, so you have to allocate storage, pass the storage in, and then use the result and then release the storage. And I was like, what? Why isn't it doing it for me? Well, I mean, I still want it to do everything for me. But I hadn't seen any of that. It was always just, you do this and it happens right. And you get a whole
Nothing could ever go wrong.
Nothing could ever go wrong. And so you get a whole bunch of people coming out of school. I mean,
that have only been taught happy path programming.
Happy path programming. And because I know this is one of the things that I know in particular Cody has been really focusing on, because, he's only been out of school for a couple of years. And it's like, testing. I want to know more about testing because I don't trust this code, which is great. I'm so glad he has that attitude.
Yeah.
But he's had to go through the path of learning testing himself. And that seems so fundamental and I think they had to teach themselves Git as well.
Wow.
Just all of these things which are we use them all the time, but I understand why you wouldn't teach them in a theoretical computer science program. But
I think the part of the path that we're on with programming languages is to make it more explicit the expectations that we can have when we call something. But the trade-off to that is that it can get really challenging when so much explicit information is conveyed. And so I think what we're discovering is ways to not make it so hard to deal with the explicitness that's being conveyed through those function calls. So I think the Kotlin null syntax is a great example of that. It's like, okay, we know that we need to convey nullability in the type system. And we've discovered that ADTs are a great way to model that.
Mm-hmm. Well, I mean, at least my view of it is that there's two different things. There's handling nulls so that they don't happen. And then there's using null as the failure return type. But because you have that null handling, the compiler forces you, see, that's the thing, because when you get back an either or whatever, you don't have to, you don't have to check the failure value. You can just pretend that it's okay.
Yeah.
You can just do
happy. You can do that with Kotlin too. It feels dirty. And I think that's part of with error handling. Mm-hmm. It's how dirty does it feel to ignore the possible error condition. And with Scala and monads, it feels really dirty. Like I feel like I need to take a shower if I call .get on something that could fail, which is basically just saying ignore the failure.
Mm-hmm. And in Kotlin, you have to say, you have to get like really explicit about it. You have to go bang, bang.
Bang, bang, yeah.
And that's glaring at you.
Yeah.
It's like, yes, I'm being arrogant here and thinking that, no, it'll never fail.
And I think that's part of the counteracting the happy path programming is to say, this feels really dirty to ignore this error. And we're going to make you do something that should jump out in a code review and say, this is really bad. And
you can easily grep for it. You go, right. We've got some null pointers. Let's look for the ignore the null operators.
Well, I bet there's a compiler flag or a build plugin that would say, don't let this code compile if a bang bang is put in there. Scala has some modes, but you can say all warnings are failures. Mm-hmm. And I think Kotlin has the same thing. Mm-hmm. So a warning would be, hey, you called .get on this thing, or you did bang bang, and all of a sudden you can turn that into a compiler with a compile flag. Mm. Yeah. So I think we are culturally shifting from happy path programming, but I wonder if universities are shifting, and that's maybe where
They've always
a lot
been
of
slower.
change needs to happen.
Yeah.
It's like our programming languages are certainly shifting.
Right.
I mean, even Go, like, it made it explicit that every function can return an error, right? It's like the tuple return type.
Well, that's the style, but it's not enforced.
Okay.
So that the idea is that you return effectively in either.
Except for they use like tuple syntax for it, which is super weird. But
yeah, because they have support for tuples built in.
Yeah.
I mean, like Python does.
Yeah.
So,
but what was weird about that in Go is that a tuple should be an and ADT, right? Like conveying that two values can fill that space. In the case of a
that's what you want.
Two-value tuple. That's, I think, what Go's kind of style was
yes.
And then you have to check, like, did you return the value or did you return the thing? Whereas really an or ADT is much better fits what they're trying to convey, because no, it's either a value or it's an error.
We should probably remind people, because you're throwing around the term ADT.
Algebraic data type,
right?
So
but what does it look like?
So there is the or and there's the and. The or is a dog or a bird, or a dog or a nothing in the case of something nullable. And so the type system conveys that you can either have a dog or a bird. You can't have both. And
you don't have to wrap those up into an object, or does that automatically create the object that comes back?
So people have usually seen these or something very similar to these with enums. So the way that you do it is if you've said that my return type is a dog or a bird, then you return either a dog or a bird, and it
comes back as a dog type or a bird type, or does it come back as a box containing a dog or a bird?
It comes back as a wrapper that the actual type would be dog or bird.
Right.
So I think the way that most compilers do ADTs is they actually generate types that are the ADT, the aggregate type.
So when you say this is a dog or bird, it goes, okay, I got this. I'll make this little package that can contain a dog or bird.
And so then usually pattern matching is the way that you then deal with what you actually got. And
so it eliminates the need for an either or a maybe or whatever.
An either is a way to do an either in Scala or other languages have eithers as well, is a way to do a or type with a wrapper. So you are not having the compiler give you a type that is the ADT. You are explicitly defining.
You're creating it, but if it's supporting this, then it just does that for you and makes it a little more seamless.
Yeah.
Right. Yeah, because I always felt awkward using that. The lefts and the rights and everything. I'm going, that doesn't mean anything.
Right.
And I haven't liked that. Whereas and also
your pattern matching is much cleaner because you don't have to then pull things out of the wrapper. Your pattern matching can just say case dog, do this.
Yeah. Right.
And it knows how, the compiler knows how to take that or type that it created for you and unpack in the pattern. Yeah. And unpack it.
Right. Yeah, that just seems that would have been a much easier thing for me to absorb rather than trying to figure out the ethers and the.
So there's also the and ADT, which is, let's say that I have a type where I need a dog and a doghouse, and I want those in a single type. So the way that we see these is through data classes, case classes in Scala. Other languages have other ways. New record types in Java are essentially the way to model an and type. And what that's saying is that I have a type that holds a dog and a doghouse, and we would call that, I don't know, yard with dog or something like that. And so we would give it a name, and then we'd be able to extract the individual pieces out as
so it's almost like just building the class for you that we would normally do by hand.
Yeah.
Well,
Yeah. So, but if you have a language that has an and ADT, then you don't need to explicitly define the like case class or data class. You
sure.
just say dog and doghouse, with and or whatever, or single and. I can't remember what Scala 3 does it. And then it generates the type that represents that, like it does in the case of or. Tuples are essentially exactly this. Tuples are ADT and ADTs with it because they don't have a name, but there is a type that you get that represents the
it's a data structure, but it's unnamed. It's like the lambda equivalent of a data structure or something.
That's
like
right.
That. Yeah, that one doesn't. I mean, I guess because I'm so used to making my own named classes, that one doesn't seem as essential to me as the or.
Yeah.
Because it seems to me like the or solves that problem of the ugly object coming out that I have to then unpack.
So the next level of error handling back to like nullability is, let's say you have a function that returns a dog or nothing, saying that maybe you couldn't find the dog. Maybe.
Sure.
And so you get the
dog's
nothing.
Escaped.
It's escaped. Yep. And so you get nothing. But what if you want to add more information or more possible error handling scenarios into that? So let's say that it could be nothing, or it could be service was unavailable. And you want to convey that information in the type system so that then the caller can decide what to do in that case.
Not just
right, because nothing could be I couldn't find it. I tried and I couldn't find it.
The network's
down. I tried and I failed to actually try. Or
it's not
whatever.
in the dictionary. The network's down. Something's gone. Yeah, it's like, well, and this. So I was just describing this in the very introductory chapter in Atomic Scala. I ambitiously decided to say, here's one of the great features about the language is that it's more than just like how do you deal with no result? And part of the problem is that for efficiency's sake, we go, oh, well, I have an int, and to show no result, C did this. I'll put a -1 in, or, they tried all these different things. Yeah. And it's like, and that was for efficiency's sake, because they were going, well, we don't want to use up extra storage. And what we actually do is, yes, we do want to have that extra information along with us so that we can say, why do you have no value?
Right.
Because maybe I need to do something based on that.
Yeah. Exactly.
So it's a lot more than just, and that's where I guess just null is better. Null at least tells you that no value has come back, and it's not just some random -1 or whatever value. It's not just some unlikely value that could actually happen.
Yeah.
But it's still not enough information, in my opinion, to be able to actually, deal with the error. It's not that different from throwing an exception. The exception can sometimes carry more information, but still, yeah.
So taking ADTs even further, you can, this is kind of outside of the realm of the way that Kotlin does it with nullability, but using ADTs, you can have a function that returns a dog or and then in parentheses, so we're going to group this next block together. So, or a nothing, or a nothing, or so you could even and these things together.
Yeah,
so,
a dog or a nothing and the reason for nothing.
Right. Or you could do it and say a nothing or a network error. And so then you can start to compose together through ands and ors and through grouping of things, which we're all familiar with from algebra, grouping these things together to define types that actually semantically convey the reality of what happened when you called this thing.
Mm-hmm. Yeah, which is ultimately what we need in order to be able to chain these operations together.
Yeah.
So.
On the subject of algebra, I saw this great video on Twitter where this girl was asking, why was algebra invented? what problem were they trying to solve when they invented algebra? I thought it was fascinating. There was a few. Most people are just saying that it was a really good question, because I guess she got bagged on for people thought it was a stupid question, but actually it was a really smart question.
That's an excellent question because, well, and it's the kind of question, because I was just thinking about this in terms of, our monad description where people go to, it's a monoid in the category of endofunctors, and it's like
doesn't describe
it
why.
doesn't, and when you present that to somebody who's like just trying to program, they're going, why are you telling me math?
Yeah.
And when you're in math class and those obnoxious people would raise their hands and go, how do I use this in real life? And it would bug me. And now I go, they were asking a good question. That is because, just saying learn math, it's like in Rick and Morty. He keeps, the math teacher keeps saying math is so important. It controls everything in life. And, they're not connecting with that. And it's like, you really do. And it's the same with explaining monads. If you explain it from the mathematical end, nobody's going to get it. But if you say, hey, we want to chain functions together, or compose them, or we want to do this thing and not have to deal with, then that's when it first started making sense to me, is when I could see it that way. And so asking, I mean, now I want to know who said, hey, we should have algebra, or just the idea. I mean, it's almost like what I was musing about earlier with zeros. It's like you have some things and now you have nothing.
Right.
Nothing of what, you could have nothing of anything, whereas you can only have 5 chickens, or,
right.
And coming up with zeros and ones and how they're different from all the other numbers. Yeah. When you really start thinking about that, it sort of blows your mind. And it's the same thing. I mean, my guess would be somebody said, boy, it sure would be helpful, convenient, or whatever, if we could have something rather than a number, we could say placeholder for a number.
Right.
And so, no, I think this girl should probably be a mathematician.
Yeah.
Because she asked that question.
She also asked something along the lines of, is math real? Like, did we discover this thing?
She's a mathematician. She should definitely study math.
Did we actually discover this thing that existed, or did we just create a concept to help us explain something that is deeper and unexplainable?
And I think the answer is yes to both of those, because there is pure math and applied math. And when I was in physics, and in engineering, I was studying applied math. And so we were just looking at, moving things around and seeing if we could, I didn't understand this at the time, but seeing if we could get the equation to represent what was going on in the real world. And you didn't care whether, it was math, it had to work mathematically, but it wasn't like deriving a theorem from first principles. It was just going, well, the ball's moving this way, and so based on our experience, we'll say that it has a, partial derivative of this and that. I didn't know what was going on at the time, but they were just trying to piece these things together. Now we would use machine learning. Right. We would go, let's look at all this data for all these balls and then come up with this model, this model. And that's all we were doing.
Yeah.
But both of those things are super important,
So I think to her question in regards to algebraic data types is, why algebraic data types? Like, why do we have them? And for me, I think what it comes down to is that we most of us understand at least a little bit of algebra. We understand that plus is commutative, right? Is that the one where you can flip it?
A plus B is
B plus A.
B plus
right?
A, yeah.
And so we understand these basic algebraic laws because around multiplication and addition, because we were taught those in, I don't know, what grade was that? 5th grade, 6th, 7th grade, anywhere, somewhere around there. And so even though I can't remember the laws and can't remember the names and what they actually mean off the top of my head, I've internalized those rules. And so when I encounter algebraic data types in a program, it makes sense with the expectations that I can place on those types. I know that if I have a dog or bird type, it's the same thing as a bird or dog type.
Mm-hmm. Right. Right. Yeah. Actually, the thing that really hooked me, I think Bill explained it because I wasn't sure when he was talking about algebraic data types, he was saying, suppose you pass it in as an argument. So you could have a dog or a bird or a football. And it says, then in your, pattern match, it's explicit. It's like not a final class. What a closed sealed class in Kotlin. And so then
those are the only things that it could possibly be.
So there's no else. And if you change the signature of your function, the compiler says, oh, you're missing one here.
That's right.
And it's like, oh, well, that's nice. That would be a little bit better than what we have. But then these other things that you're describing make it even more compelling.
Yeah.
So,
yeah.
So and are there any other languages than Scala 3 that has those?
Like built in, there are. I'm sure like mathematical languages have them. Idris or whatever probably has it. So Coq is another one that I think has led a lot of the research in these areas. So I don't know a whole lot about them, but I think we see them in a lot of languages, but they haven't necessarily been called algebraic data types. Like we've seen tuples in languages for a long time, but people haven't referred to that as an ADT.
Yeah, and it allows calling it an ADT allows you, I think, to think about it a little differently. Because Python has had tuples forever,
right?
But I've just thought, well, if you want to return more than one type, you use a tuple and unpack it on the other end. If it gets too unwieldy, you turn it into a class.
Yeah. Yep.
But just
you give it a name.
You give it a name. It's just very. In fact, they added a feature called name tuple. So you
shouldn't that just be a class though? Like maybe syntactic.
Well, it was added a long time after tuples were in. Yeah. So apparently there was a perceived need for it.
Yeah.
And people are, I think, pretty enthusiastic about it. I've not really used them very much, but maybe I'll internalize it and start using them.
Yeah.
But yeah, I typically prefer a named, just a class because. But anyway, people find value in it. So.
Yeah, there are times when I'm prototyping something and I don't know what the name should be, where I use a tuple, and then after I've explored the domain sufficiently and have arrived at what the thing
is,
then I can give it a name.
Name it, yeah. So it's nice.
But sometimes the name can get in the way. Like, because sometimes the name that you would come up with would be like dog and bird and football would be the name of the type. And it's like,
that's not very helpful.
Yeah, it's not very helpful.
Yeah. Well, and I think being able to do it, with the, the monadic approach, I much prefer the ADT because I don't have that name in the way. I know that I'm either getting something or I'm getting error information or it declutters it. Yeah.
So taking this just a little bit further, which is something I'm learning about and not an expert on, but I find fascinating, is that there are let's say a dozen kind of usual algebraic laws like commutativity, associativity,
reflexivity. Is that one of them? I don't
know. There's a bunch.
Yeah.
But what's interesting is that the rules can get applied in different ways. There's a matrix of how these algebraic rules can get applied, and so we can actually give names to different ways that different rules get applied together. And so there's I don't know all of them, but there's like lattices and monoids and then monads. And so there's all these names for just different structures of these laws together. And so I think that right now ADTs are coming up in a lot of programming languages. And what we may see over time is more of these aggregations of algebraic laws and the names for them percolating into programming in other ways as well. So that'll be interesting to see how that plays out. But
it is.
Where it's hard is that in 7th grade algebra or whatever, I learned addition and the algebraic laws of addition and multiplication. I didn't learn the algebraic laws of monads.
Right. And I
learned the laws. I didn't learn the term.
It was also hard to, I could just plow through and do those things, but I realize now that if I'd had some kind of motivation behind it, it would have just completely changed my perspective. It just seems like there was a lot of wasted time there, which could have been put to better use, but
yeah.
That's a different. So let's see. We got partway through, or we got a lot of the way through discussing Kotlin features.
Kotlin 1.4 was released last week too.
It was last week.
Exciting. I switched some apps over to it, and everything just worked, which was awesome.
Yeah.
But reading the release announcement, there wasn't like a ton of programming model changes.
Mm-mm.
It seemed like a lot of internal stuff to me.
There was a lot of internal stuff. Yeah. They've
coroutines and fiber, like there was internal changes to that, but
yeah, I mean, the single abstract method stuff.
Oh, that's right. Which is an optimization for JVM bytecode applications.
No, it's a programming thing. So you're able to say, if you have an interface that has a single member function in it, because that's what we call them in Kotlin, and you put fun in front of, so it says fun interface, and then the compiler will make sure that you only have one.
Oh, cool. And then you can use it as a method reference. So just like in Java, like I think Java
it's modeled after Java's.
It's the Java single.
So if I want to implement that interface, I can just, for example, like use a Lambda,
right?
And the Lambda's single function will fit that, and I don't have to do all the rest of the stuff.
Yeah.
And I don't, say have to have a name. So I can say return interface name and then give it a Lambda.
Yeah.
And so from a succinctness standpoint, it's really nice. And I went through the book and found all the examples that I could, and either just did them as SAM things or did them both ways and said, here's the old way, here's how you can do it with the SAM. So
nice.
Yeah.
So have you updated the book to 1.4?
Oh yeah. I mean, we were working with early versions of 1.4 all along, but there wasn't any, it was just additive stuff.
Yeah.
But and I've kept it up to date with the latest Gradle, all the latest versions that have come out. So it's basically 1.4 compatible. And yesterday I finished the text of the book. We still have exercises too. I mean, the exercises and solutions are all done, but they need to be converted into this form so that you can do the exercises inside of IntelliJ IDEA, and it gives you hints and answers and things.
So atomickotlin.com, people can...
atomickotlin.com, they can go there, and it has all the instructions.
That's
and
awesome.
The book is through, there's a system that JetBrains, I don't know if they own the company outright or they're just supporting it. And then there's LeanPub, which has been very useful. Nice. And so that's how you get the book. And then the print book will be, I mean, it's ready. It's just, we have the cover. There's needs to be some adjustments with the spine and things like that. But I think it'll be remarkably soon that the print book will also be available, and it should be assuming the Ingram Spark thing goes well, it'll show up everywhere. It'll be available everywhere. So anyway, yeah, we'll see. You never know about these things, but it's been,
that's cool.
Yeah,
exciting.
It is, and I'm very pleased with it. It's I feel like it may be the best thing that I've done, but I don't know. So
yeah, I'm excited to go through it.
Yeah,
I think I read through some very early versions of it.
Probably if it was a while back. There's a lot of rewriting.
There's some things I need to learn. Like, what's the by thing? So in Kotlin, you can say foo by lazy or foo by some other identifier or something.
That is delegation.
Okay.
So you can say, I want to implement this interface using that object.
Okay.
And it enables things like lazy or late initialization. Mm-hmm. So lazy initialization allows you to have a non-null reference. So it still has that non-nullability benefit that you have, but it doesn't get initialized until the first time you use it.
Right.
And then late initialization is...
So is lazy actually then a keyword in Kotlin, or... Because I've seen by and then other identifiers as well.
Yeah. It's not, by is not just lazy. It's delegation in general. So another thing that you can do with delegation, which is really nice because it's kind of halfway between inheritance and composition. Uh-huh. So delegation would allow you to say, all right, I want to create this object from that other object, but I don't want to inherit from it. I want, maybe I'm already inheriting from something else and we can't do multiple inheritance. Yeah. You can do multiple delegation and you can still upcast to the multiple delegates. Yeah. So you get, which is really what multiple inheritance is for, is if you want to upcast to more than one base type. Yeah. So you get that with delegation. But what's really nice is you can say, okay, I've got this thing, I've got a couple of methods, and I want the whole kit and caboodle from this other object, but I want it to be exposed as my interface, not just a member object that I then have to, write all the functions to call those things to delegate. So it just does that in one. Yeah, it's very powerful. Scott Myers first explained it to me, and he really thought it was a powerful concept, and it is. It's very powerful, and it's not.
So it's just it's kind of another way to do polymorphism.
Well, yeah, I guess because you can upcast. So it's more, I think of it more as a way to assemble objects with less code because, and maybe you're right. Maybe it should be thought of as another way to do polymorphism. But my first impression was, I want maybe a couple of objects in my other thing, and I want their interfaces to be exposed together. Yeah. And I don't want to have to write all those, functions that are simply saying, okay, call this, call this. And it does it for you. So, but then it also enables things like the lazy and late initialization stuff.
I wonder if it's back to ADTs. I wonder if it's also another way to create a product type. Maybe if it's special syntax for generating product types.
I guess the trick would be to figure out what you can do with delegation and what you can do with ADTs and see how much they intersect. Yeah. If they do intersect. Yeah. We need a mathematician to do that.
Yeah, we do.
Yeah. So, but yeah, no, it's a very powerful thing. And we have multiple atoms in the book on
delegation.
Because it's used. There's basic delegation, and then it's used in a number of different other ways. So interesting. Yeah, it is. But very powerful syntax. So yeah, one of the things that I don't think we emphasized a lot when we've talked about it before is just the syntax simplicity and clarity and the less code. And like I've forgotten it now because I'm used to using both Python and Kotlin. But then when I come across, well, my friend Luciano, who wrote Fluent Python, he's quoted me as coming up with this term, semicolon languages,
Huh.
which is to me a language where the designers felt like the compiler writer was more important than the programmer. That's pretty harsh, I know,
Yeah.
but it's kind of what I mean. I mean, and I was just telling you about this one language designer who wants to keep semicolons in, and when I objected to it, he says, "Well, you still put periods at the end of sentences," which I don't know what to do with that. But to me, if I see semicolons in a language, I'm going, "Oh, that's what you think of me."
Right.
As a programmer, you think, "Oh,
I serve you."
Yeah, I serve you so that you don't have to figure out how to find the end of an expression.
Right.
And so, I mean, not having semicolons, it just seems so archaic to me now.
Yeah.
And what didn't I see now? I've forgotten. Did Scala get rid of semicolons?
They're optional. So
they're optional. Okay, well that's fine. I mean, they're optional in Kotlin too.
Yeah.
So so they led the way with that. Yeah. Well, I mean, Python did too. Yeah. But and then comparing it to Java, being able to have top level functions rather than forcing everything to be a class. That was just they were trying to make it small talk. So
yeah.
And I
had this interesting thing recently where I started applying KT-lint, which is the Kotlin linting tool.
I did not know about that.
To some projects, and it out of the box it was pretty strict on ordering of imports, which is interesting because KT-lint had different rules than IntelliJ. So, but it would check the file name against the class name and stuff like that. There was rules to me that seemed like, okay, if I'm working in a team and I want all the code to be structured the same and look the same, like these are useful rules. But then there was rules that were, oh yeah, like this should just be every Kotlin programmer should abide by these rules. And so, it was a interesting, useful experiment. And I did it in this case because my pull request was being marked as failed because the pull request was automatically having KT-lint run. And so then I had to add KT-lint and get it to work locally so that then I could get my pull request to get a thumbs up. So.
Well, I like those things because I know we used to have arguments about code formatting and style and this and that would just go on forever. And for me,
apply an automated formatting standardization, and the argument, because there should never be any formatting, bike shedding review. Like, no. I think I tweeted recently something along the lines of, if a code review involves discussion about formatting and code structure,
it's a huge waste of time.
Exactly.
Automate it. Exactly. It's like you got to be thinking of it in terms of, we have a team, everybody has to read the code. I'm sorry if this doesn't fit with your personal coding style, but that's not the most important thing.
Yeah.
And if you think it is, maybe you're not a good fit on this team.
Or we've automated this. Yeah. So KT-lint can also auto format your code for you. So it's just like automate it so that, and yeah, if you like formatting code a different way, like, sorry, like just.
Yeah. It's not, it's a communication. It's, I don't know.
It's like, I hate Go's formatting style, hate it. But when I'm writing Go code, I abide by the Go formatting.
Because you're gonna,
Because I'm working on a team with people,
and tabs, man. Why? Why would you do that?
It's just like they offend me, to the point where in IntelliJ, I have tabs show up and spaces show up. And if I see that like arrow, like it's just this visceral reaction. So when I'm working on Go code, I tell IntelliJ to don't show me that. Just don't show it to me because
it's going to annoy me.
Exactly.
It is, yeah.
And when I don't see it, it's fine.
Yeah,
I get through coding just fine.
I could see that. I could see that. Yeah, there were a lot. I think there were a lot of things that Java imposed on us. That one of the things I love about Kotlin is that it releases that. Like, I mean, having to put everything in a class, having to put one class per file, the tying the classes and the
Yeah.
files together, and then that deep
Having your directory structure have to
having the
match
directory
your,
structure filled with empty directories
yeah.
just so that you could, and I understand what they were doing. They're going, okay, let's make the directories meaningful and all of this stuff will be meaningful. But it was just, I feel like it was somebody who didn't understand Smalltalk well enough and certainly didn't understand C++ well enough
Yeah.
to say that.
I think before tools were sophisticated, maybe there was some value to being able to know where a particular definition resided.
Mm-hmm.
But now with tools, you just control click on the thing and it takes you to it.
Mm-hmm.
Like,
yeah. But I mean, to Java. So the way I presented Java in the Kotlin book was I said it did two really important things for us. And it was basically bringing these ideas into the mainstream that we previously thought were impractical, which is garbage collection and virtual machines.
yeah.
And before that, it's like, well, yeah, we knew that. I mean, Python has garbage collection, and it predates Java.
Yeah.
And there were some others, but they were like not real languages. They wouldn't run fast enough. They wouldn't be practical or whatever. And then virtual machines we saw in the UCSDP system. But again, that was like super slow.
Yeah.
And so people go, oh, no, those are impractical. And then Java comes along and it goes, well, both of these things we're showing you can use them. The rest of it was, we're moving on from it, I think.
We are moving on. Yeah.
I hope so. Yeah.
I think Java is continuing to evolve and getting some great features.
Oh, it is. I mean, what Brian Getz is doing with Java is like mind blowing. I would have looked at it and said, this is hopeless. And he goes in and he like pulls these magic tricks out of his hat that are just like, that's why he's so brilliant.
He is brilliant. And as I've heard him say, he has last mover advantage, which I just love. It's their advantage is to let everyone try all sorts of stuff, and then once all the experiments have been done, then they can adopt what works.
So. Well, that's basically what Kotlin did. I mean, because virtually all of its features, except for extension lambdas, that's that feature they invented. But every other feature they lifted from another language
proved
after it had been
else.
proven not just that it works, but that people got a lot of value from it, which is what I really respect about that decision-making process.
Yeah.
And like, they put in things like ranges, which are small, but really nice, just being able to say 1.5 rather than, range, rather than calling a function. It is nice. Eliminating the new keyword, which was never necessary in Java. It was like just a misunderstanding of what C++ did. Yeah. C++ had to have it because you could either have things on the stack or on the heap. And so to say it's on the heap, we had to have new and we had to have delete.
Interesting.
But once you have a garbage collector, you're creating everything on the heap anyway. And so you don't need a new keyword.
Yeah.
I mean, a few other things.
Yeah, Scala 3 is getting rid of the new keyword. They're making it optional, I should say.
Yes. Right, but, so that but effectively getting rid of it. Yeah, which is really nice. Great. And and there's a bunch of other things that they did, which initially they had, like main was more like I don't know. I guess it was kind of like Java's. You had extra things in main that you like the arguments to main you would never use.
Right.
And
KT-Lint told me that on my main function that I wasn't actually using the arguments.
So you can take them out.
Yeah.
Okay.
I was like, thank you, KT-Lint.
I find it so annoying. I mean, like Java's, hello world in Java. You got a class, you got a system out print line, you got to have a public static void main, you have,
Yeah. You think about all the concepts you have to understand to like really understand hello world, and it's a dozen right?
It is. It's a lot.
And in Kotlin, what's your minimum? Just fun main, open parenthesis, close parenthesis,
Open curly brace.
open curly brace, and that's it, right?
Print line hello world.
Yeah.
Yeah, and you can explain it like whereas in thinking in Java.
So the concepts there that you have to understand are a function.
Yeah.
If you can understand, not even arguments, not even types. Like there's no type.
No.
I mean there are types, but they're not
implied.
They're all implied, inferred, implied. Yeah. But yeah, so that's really nice.
Yeah,
you have one concept you have to understand for Hello World.
Because when I wrote thinking in Java, my rule was I'm not gonna do the thing that so many people do. Go, well, don't worry about this code. We'll explain it later. I'm going, no, I'm not going to give you hello world that you don't understand all the pieces of. And it took a lot of writing before I could do hello world in Java. And so, I mean, things like that.
If you're trying to avoid forward references in Java, it's like a dozen chapters before you can get to hello world.
Mm-hmm. No, it was
in
a
Scala,
lot.
it's probably like 6.
Mm-hmm. Yeah.
Python, it's like none, right?
None, because you don't even have to have main.
Yeah.
You just say print hello world. The default is scripting.
Yeah.
And then you can go from there, which is pretty brilliant when you think about it.
Yeah.
I
think with KTS, it's the same, right?
The Kotlin scripting.
Kotlin scripting.
Yeah, I actually haven't done any Kotlin scripting.
You have in Gradle, right? So Gradle now.
Well, we built
Kotlin
it
DSL
using
KTS.
We built it using Groovy.
Oh, the Groovy DSL.
And so I kind of haven't touched it because we have everything's automated.
Yeah.
So I kind of haven't touched it, but I am thinking, boy, maybe in the second edition we'll make it all, because it seems like, yes, we should be using Kotlin scripting and for our Gradle things. But Gradle, it's like, if it works, I don't want to touch it because it doesn't make sense to me. Gradle doesn't make sense to me.
It doesn't make sense to me either. I've come to appreciate SBT a lot more because of Gradle, which is saying something.
Yeah, and I don't even know how to ask questions about Gradle. And we know the guy.
Yeah,
we both know Hans.
But I think the challenge is that, like what we've found with declarative DSLs is that there's always a life cycle that is behind that DSL. And in the case of Gradle, the life cycle of your build definition gets intertwined into the life cycle of the build in a way that is incomprehensible to me.
To me too.
And so that's one of the things that purely declarative builds like Maven, it's nice because you don't have to think about how your state modifications, when and how they get applied to the build tool's state management and life cycle. And I think that's been the hardest thing about Gradle is I just don't know how and when state changes are happening between what I write and what the build tool is doing. So, anyway,
well, at least you understand it well enough to even explain it that way, because I'm not, I'm just looking at it going, okay, I need to put this in here and now it works. But if I put it in a slightly different way, it doesn't work. And I mean, I used Make for years, and it's like, Make has got lots of limitations, but it was super fast. And it was like, this depends on this. And when the dependencies are out of date, you do this.
Yeah.
It's like, there's Make for you in a sentence.
Yeah.
And it's like, I don't know how to describe Gradle, but it works. I can use it.
Yeah. There are some very nice things about Gradle. Gradle's caching is amazing. Their dependency management stuff is really great. They rewrote the whole Maven dependency management stuff, and they did a really good job with that. I do like getting to write my builds in Kotlin, but it does have the side effect of that the state just being magic
Mm.
and very hard for me to debug. So there are some things I do really like about Gradle.
Yeah, I guess my thing is, as much as I've used it, I still don't like, if I want to do a thing, I don't know where to start. I don't know how to, and I've
Yeah.
read books on it, and I've read the docs, and I've worked with these files, and it's like, I can, if somebody's got it working, I can look through it and go, oh, I guess I sort of see what's going on, but not enough for me to go, oh, I want to do this thing now. Here's what I do.
Yeah.
And it's, yeah, and build tools.
Yeah, build tools. There still isn't one that is the
No,
silver bullet.
no, and I think to figure that out, maybe we need a mathematician again, somebody who says, what is the essence of a build tool?
Yeah.
Well, and then that language that you were just talking about,
Unison.
unison.
Yeah.
See, they're looking at it in a different way, because
Totally
you would
different way.
think that would be able to know. I mean, the language would know if something is out of date.
Yeah.
Yeah. So,
Yeah.
maybe that's the problem, that we've just been looking at the problem the wrong way all this time, or something.
Yeah.
I don't. Yeah, I don't know.
I had a thought this week about build tools, which was, why do I have to like run my compiler when my code changes? Like, shouldn't a compiler understand a stream of file changes instead of just, because the way that I think most compilers work today is you run the compiler, it gets a bunch of files, and it does what it needs to. Why isn't there a compiler that instead can receive a stream of file changes? And so the compiler can remain running. And whenever a file changes, it then knows, oh, okay, that file changed. Here's what I need to update, right? It's like, fundamentally, we have not looked at compilers as file stream consumers. Because what happens in a compiler is you've got all these phases. You have to come up with like this whole tree of information about, the whole graph of the syntax and types and all that kind of stuff, right? And so it has to compute all this information every single time it runs.
Mm-hmm.
But as a developer, like, I'm changing one file at a time, and why can't the compiler come up with that tree of information? It is then reading a stream of files and says, oh, I've already computed everything except for this one little piece. And I think that compilers have a lot of this mechanics through caching, is that they know what things they don't need to recompute now, better than they used to. But it seems like a better architecture would just receive a stream.
I would argue that IntelliJ is sort of that experience. I mean, because it has, this is so embarrassing, because it wasn't until like last, I don't know, November or December, that I started using the JetBrains products.
Yeah.
And I was just using, my text editor before that.
Yeah.
And then I started using them, and it was like, first I used IntelliJ, because I thought, oh, well, I'll just, I'll do this. I was forced to, or whatever, for something. And then it was like, oh my gosh, this is doing so much more for me than any of the other things. And then I immediately switched to PyCharm for Python, because that also does things.
Yeah.
Oh, and it has a plugin that looks at your code and makes suggestions more than just what PyCharm does, but there's an additional plugin, which I forget the name of. Nice. And it's like, oh, you could write your code better this way. I'm liking that. But my experience now with using, say, IntelliJ with Kotlin is that that's how I find out whether things work. And then once that's working, then I run my normal build just to double check.
Yeah.
But it is, I mean, I feel like it's very similar to the experience that you're talking about. It's just constantly checking things.
Yeah. I think you're right. I don't understand the internal architecture very well of IntelliJ, but I think that it is probably more similar to the model that I described of maintaining that state and then getting a stream of changes so that it doesn't have to continually recompute. all of that state.
Mm-hmm. And it does seem to cache it. Like, and maybe this is one of the things that happened in 1.4, because I feel like I started noticing, like, because I've got my whole book in a single project.
Yeah.
And so, sometimes it has to rebuild everything, but then a lot of times it doesn't, and it's just boom, the answer is right there, and it doesn't, because so it's caching all of that. It's knowing what's already been built.
Yeah.
So
yeah,
it's just, I mean, such an amazing experience. So much time wasted not using that tool.
Yeah. There's some interesting innovation happening in this particular space where you've got your compiler and it's having to come up with all the information about your program. And then you've got your IDE that is also having to come up with all the information about your program. Wouldn't it be nice if you could just unify those two? And so this is the language server protocol. I think it's called LSP.
Mm-hmm.
And so Scala SBT just added support for this language server protocol thing, and now tools are beginning to consume that information and provide it. So VS Code, I think, is the primary driver, and Microsoft are the primary drivers of this protocol and doing this. And so I think they've been doing a lot around TypeScript in VS Code. But the really interesting part of this is that now you have essentially your compiler is providing one way to access all the information it needs about the syntax and the types.
So it doesn't have to be reinvented in every tool.
That's right. Exactly.
Right, which makes a lot of sense.
Yeah. So I think I'm excited to see the innovation happening in that particular space. Now, IntelliJ has not gone this direction because they've got so much investment into the indexing protocol that they've already invented. And it's really efficient. It's been, created around, like, I don't know, 100 millisecond responsiveness, getting an answer from the index. And so I can see why they haven't necessarily embraced
just jumped, because it's going to be a huge thing for them. Yeah. But eventually probably they'll move over, I suspect.
And as I think more compilers implement the protocol, like I don't know what Kotlin's plans are for implementing that protocol and that sort of thing. But but yeah, so there's interesting innovation happening in that space.
Yes, it is. Are we? I think
we're at an hour.
We're at time. Yeah. So that seems to be what we do is an hour.
That's it.
Yeah.
And then we're out of thoughts.
And we're out of. Well, no, we have many more thoughts, but we need to save them for our next time.
That's right.
Yes.
Until next time.
Until next time.